Okay, this is the Math 990 Module 6 Reality Check, Video 2. So watch this if you have been struggling. The first video we kind of went over how to do number 1. We used this formula. Okay, now we're going to talk about the others and just how to set them up. So number 2, we're asking when will the rocket return to the ground? In other words, when will the rocket return to a height of 0? So that's kind of the key word here, the height of 0, okay? Well, notice in our original equation up here, it says the height of the rocket is this, where h of t is the height in feet. And so on number 2, when we're going to set that up, what we're going to do is we're going to put 0 in for h of t. So we'll have 0 equals, and then the equation, negative 16t squared plus 48t. And then you'll need to solve for this. Now when you solve for this, notice it's t squared, which means there should be 2 answers. One of them might be a little bit tricky to find, but, or maybe not. It might not be tricky, but, so yeah, you've got to solve for this, but you use that original equation and the hints it told you, or how it defined it, such as the h of t equals the height. And so when it says the height is 0, like on this one, we have the height is 0. Well, we know that means then we just put 0 in place of that h of t. And then we're just going to solve for what are the values of t when the height is 0, or basically what are the times when the height is 0. Now, let's go down to our graph. We'll skip those two for a minute. So for our graph, hopefully you've started putting some points on from number 1. So we're going to have time on the x-axis and the height on the y-axis, okay? So that's your y-axis. So for time, I would just say here's 1, here's 2, here's 3, here's 4, and then for height, I would just go by 5. So 5, 10, 15, 20, 25, 30, 35, 40. So we know from number 1, we found that at a height of 32 feet, and this is from the first video, at a height of 32 feet, that happened at 1 second and 2 seconds. And if you think about the trajectory of a rocket, it's going to go up and down. So it makes sense that there'd be 2 points that are at the same height. So we've got 32. So at 1 second, we're at 32. And then at 2 seconds, we're also at 32. Now on number 2, you're finding what we just set up. You're finding what is the height at 0. And so you're going to have something along here. You're going to have a height of 0, but you have to figure out how many seconds does it take to be a height of 0. Okay, so just go along and put in the points as you go. Okay, let's look at 3. So you're going to find an answer to 3. We're looking for when will it return to a height of 0, but you'll also, just because of the way it's set up, it'll also give you the place that it starts on the graph, right? And so you'll have somewhere on the graph that it starts at 0. That'll be one of your answers. And when it ends at 0. When you find them, it'll be pretty obvious which is which. So now on 3, we're looking at the time that it reaches its highest point. And it tells us the answer for this. It will be exactly half the time it takes for the entire trip. Well, if you think about the rocket, the time it takes for its entire trip is going to be from start to finish. And you've just figured that out on number 2. So the time for it to reach its highest point is exactly half the time it takes for the entire trip. Okay, so it tells you exactly how to do this. This is going to be a short problem if you've done 2. And then let's look at number 4. We need to know the maximum height the rocket reaches. Well, we're told on number 3, we figure out the time at which the rocket reaches the highest point. So once you figured this one out, it was half the time, right? Well, we know our original formula is h of t equals negative 16t squared plus 48t. They tell us this is the height, and t is the time in seconds. So this will give us the height through the whole trip of this rocket. And so let's say we plugged in 1. If we plug in 1 for t, let's see what we get. So we plug in 1 for t equals negative 16 times 1 squared plus 48t, or 48 times 1. So 1 squared is 1. 1 times negative 16 is just negative 16 plus 48, or 32. So this tells us when we're at 1 second, our height is 32. Hopefully that feels familiar, because that's exactly what we figured out on number 1. We figured out when we're at 1 second, we're at 32. What do you think would happen if we plugged in 2 for t? Hopefully you're thinking, and if not, that's okay. Hopefully you're like, hey, on number 2 or on number 1, we also, sorry, I might have said number 2, but we figured this out on number 1. On number 1, we also figured out at 2 seconds that we're also at 32 feet. So that should be our answer. Similarly, when you plug in h of 0, you should get the answer that you found on number 2 when you plug it in. And let's see. So for this one, we're trying to find the maximum height. Well, if you look at number 3, sorry, I have to delete all that writing to scroll up. We found the time it takes to reach the highest point. And so you can use that time that you found to help calculate the maximum height. I've tried not to give you all of the answers because I still want you to think about this, but try it, submit it, I can give you feedback, and then try again.